Hi everyone, today we'll discuss calculus of one variable. The important theorem, Cauchy mean value theorem, or this is also known as second mean value theorem. This we will discuss today. Let's go for the proof of it, then will discuss the problems. So what is the statement? If f of x and g of x are two functions such that f of x and g of x are continuous in the closed interval ab, f of s and g of x are derivable in the open interval ab. Third, g dash x is not equal to 0 for any value of x belongs to open interval ab such that f dash c by f dash such that f dash c by g dash c equal to f of b minus f of a by g of b minus g of a. Now let's go for the proof of it. Let us consider the auxiliary function phi of x equal to f of x minus a g of x, f of x minus g of x, where a is a constant, to be chosen, such that phi of a equal to phi of b. A is a constant to be chosen such that phi of a equal to phi of b. Now phi of a equal to phi of b. What is phi of a? F of x, f of a minus a g of a equal to f of b minus a g of. So what I am doing is, this I am taking to this side and this I am taking to this side. So this will be f of b, this I am taking to this side, b side, f of a. Now this if you take here, the a of g of b, already minus a of g of a is there. Now a taken common, g of b minus g of a equal to f of b minus f of a. Therefore a equal to f of b minus f of a by g of b minus g of a. Call it equation number 1. Equation number 1. Call it equation number 1. Now, first part is over. This a is nothing but f dash c by g dash c we have to show. Next. Now, g of b is not equal to g of b. Suppose if g of b equal to g of a, then this implies g of x satisfies all the three conditions of Rolle's theorem. Therefore, g dash c equal to 0 or g dash x equal to 0 for all values of x belongs to interval. Therefore, g of b is not equal to g of a, or that means g dash x is not equal to 0 for any x. So which means that a is finite. This part is very important in the proof. This part is they see this part, examiner, because very important. Now next. Now we'll apply the Rolle's theorem to solve this problem, to prove it. F of x and g of x are continuous in the closed interval ab. So therefore phi of x is also continuous. How can you say? Because difference of two continuous function is also continuous. Suppose second part f of x and g of x are derivable in the open interval AB. Therefore, phi of x is also derivable. Why? Difference of two derivable function is derivable. Now what? So phi being the difference of two derivable function is derivable. Phi is the difference of two continuous function is continuous. Then also phi of A equal to phi of B. Also phi of A equal to phi of B. So that means phi of x satisfies all the three conditions of Rolle's theorem. There exists C belongs to open interval AB such that phi dash C equal to 0. So phi dash C. So what is phi of x? Phi of x we have f of x minus a g of x. So what is phi dash x? Phi dash x equal to f dash x minus a g dash x. Now phi dash c. So phi dash c equal to f dash c minus a g dash c. Phi dash c equal to 0. So this is 0 equal to f dash c minus a g dash c. So a g dash c equal to f dash c or or a equal to f dash c by g dash c. What we call the number one? Number one, a equal to we got this thing. See here, a equal to we got this thing. Number one, here a equal to we got this thing. So from 1 and 2, f dash c by g dash c equal to f of b minus f of a by g of b minus g of a. Hence proved. Very easy. See here one more time. What is the statement? F of x and g of x are two functions such that continuous in the closed interval AB, derivable in the open interval AB, and the conditional class. Third one, g dash x is not equal to 0 for any value of x. See here, for any value of x. Suppose, for example, let me change the color. Suppose, suppose if it is 0, suppose g dash x equal to 0 for one. So if you put 0 here, it is undefined. 1 by 0 is undefined. Here also if you put they are equal, undefined. Undefined means 1 by 0, 1 by 0 equal to 1 by some function. 1 by 0 is undefined. Some function will or 1 by infinity by 1 by undefined. If it is 0, 1 by 0 is infinity. Infinity equal to infinity. Again leads to the wrong result. So therefore, g dash x is not equal to 0 for any value. Further, in the proof also he will see this. Otherwise, the theorem will collapse. So consider the auxiliary function f of x, phi of x equal to f of x minus a g of a. A is a constant to be chosen in such a way that phi of a equal to phi of b. Phi of a equal to phi of b, we got the value of a. Now suppose, now given g of b is not equal. Suppose if it is equal, g of x satisfy all the three conditions of Rolle's theorem. Therefore, g dash c equal to 0 for a particular c or for all c, but which contradicts the hypothesis. Therefore, which means that a is finite. Now, phi of x, we are applying Rolle's theorem to show that phi of x is continuous and derivable. Then it satisfies Rolle's theorem. With that, we got the value of a. A has two values from 1 and 2. Yeah, hence Cauchy mean value theorem or second mean value theorem is proved. Thanks for watching. Please do subscribe my channel and share with your friends.